is the new ship you'll be working with, the AH-1G Huey Cobra attack helicopter. It is the first helicopter in aviation history to be designed as a weapons platform. It is very fast, can carry more than 1 ton of ordnance, and represents a significant increase in fire support for the Army's combat forces. The whole design was based on using many of the dynamic components of the UH-1 series helicopter and wrapping a new, clean, aerodynamic shape around them. It is this new fuselage which we should look at first, for it is a different breed of cat from the previous UH-1 models. On the earlier Hueys, all of the access panels and doors were made of thin aluminum skin. For all practical purposes, they did nothing more than cover the airframe structure. They could all be removed or opened at once, and the aircraft could be moved in this condition. The AH-1G is much more like a jet fighter. Many of the airframe panels are part of the structural integrity of the aircraft. They have aluminum or titanium faces with fiberglass honeycomb backs. They are designed to carry airframe loads and do it effectively. Let's look at the most extreme case. With the aft fuel tank access panel removed, the aircraft is in a marginal structural condition. Should someone try to move the ship by the tail, structural damage might occur. Obviously, to carry the loads which the structural panel does, a support such as a jack should be used under the tail section. As you go around the ship, you will find these structural panels everywhere. It may help you to understand why you have to remove 40 screws sometimes when you know that the panel could be held on with 6. Although the panel could be secured with so few, the aerodynamic flight loads couldn't be carried without using all 40. You'll also notice the screws themselves, flush Phillips head screws. They have been used because of the aerodynamic integrity of the AH-1G. They require a Phillips head screwdriver in most cases. The Army knows that there will be a lot of these to remove and replace, so there have been additional screwdrivers of the right size and type added to your tools for this ship. Components which produce unnecessary drag on the Huey Cobra have been eliminated. This design philosophy is apparent throughout the whole ship. Everything has been faired in or covered over. Take those rocket pods, for example. The shaped nose covers can make a difference of 11 knots in aircraft speed. But let's start walking around the ship and see where the main components which interest the airframe mechanic are located. The nose compartment door consists of a contoured laminated fiberglass panel with spring-loaded hinges and spring latch fasteners. A door on each side of the fuselage, immediately after the TAT-102 gun turret, gives access to the ammunition compartment. The cockpit canopy is 1/4 inch stretched acrylic plastic covering the entire cockpit area. The pilot's and gunner's door latches are flush mounted and located in the lower edges of each of the doors, which hinge upward and are held open by 3-position variable struts. When the jettison handles, located in the top of the canopy, are turned, the doors are separated from the canopy. 2 doors, one on each side of the fuselage, directly aft of the cockpit canopy, provide access to the hydraulic reservoirs. Construction is laminated fiberglass and honeycomb core. The engine and transmission are cowled on each side by doors which swing open fore and aft on articulated hinges. The pylon area is covered by a laminated fiberglass enclosure. Doors are provided in the center section for access to the swash plate and in the aft section for access to the engine oil tank. A one-piece enclosure streamlines the engine tailpipe. 290 pounds of advanced type armor materials have been integrated within the airframe structure. to protect the crew and vital aircraft components. Crew seats are constructed of dual hardness steel with under and side panels of boron carbide. Engine, compressor section, and fuel control are protected by boron carbide panels. The pilot seat is a vertically adjustable one-piece bucket-type assembly mounted on two vertical tubes which hold it in place on the airframe structure. The gunner seat is a two-piece bucket-type assembly consisting of a back and bottom. The two parts are joined together and held in a fixed position when bolted in place directly to the airframe structure and is not adjustable. The tail boom is an aluminum alloy structure covered by aluminum skin. As in previous versions of the UH-1, a synchronized elevator is located on the tail boom. Doors and panels are provided at various locations on the tail boom to allow interior access for inspection and maintenance. The tail rotor shaft is enclosed by sheet metal covers on the tail boom and on the leading edge of the fin. They hinge open to the right and secure in the closed position with twist fasteners. The tail rotor drive shafts are the same as other Huey helicopters. The 42 and 90-degree gearboxes are also identical to the UH-1 series of aircraft. The tail rotor assembly is similar to the UH-1C, except for a design change in the shimming method for establishing trunnion centering. A completely new tail rotor hub is currently under evaluation and will probably be installed on later production AH-1Gs. Stub wings mounted on the fuselage are provided primarily as a mounting accommodation for external weapon stores. Each wing is attached to fuselage fittings with 5 bolts and has removable leading edge sections. The alighting gear consists of 2 skid tubes and 2 arched cross tubes of formed aluminum alloy. Fittings are provided on the skid tubes to accommodate ground handling wheels. To prevent abrasion and damage from contact with the ground, replaceable steel skid shoes cover the bottom side of the skid tubes. The AH-1G main rotor is 44 feet in diameter and has 2 27-inch cord blades on a 540 door hinge type hub. This system enables the Cobra to fly at high airspeeds with exceptionally low vibrations. The main rotor assembly is the same as the UH-1C. The pitch horns are different due to the fact that the stabilizer bar of the C model has been replaced by the SAS system. The mast is also not interchangeable, since it is heavier and has a series of different splines. Now that we have been around the ship, you will have noticed that a lot of components look similar to the UH-1 series of Hueys, while a lot of components look similar, but are stronger. The whole airframe structure is substantially beefed up, and individual items, such as a landing skid, are completely different. It is stronger and attaches entirely differently than UH-1 skids. The rotor blades are the principal source of lift for the helicopter. They are made from aluminum honeycomb and are bolted to the grips at the inboard end. The blades require careful inspection for nicks, scratches, dents, and voids. Your TM55-1520-221-20 has very specific descriptions as to what should be fixed and how to do it, and what should not be repaired but replaced. Like many other areas of the aircraft, this will be one of the most important parts of your job. Knowing the difference between what you can and should repair and what you should replace. Of course, all blades must be tracked after every installation. And this is a good time to go back to the Dash 20 and see the new type of troubleshooting table which has been provided. In clear, step-by-step procedures, the entire tracking operation is detailed. And after each step, there are choices to be made, depending upon how the test worked. The swash plate and support assembly is similar to the UH-1C, except the components are stronger. the swash plate uniball friction device, and the collective sleeve collet are also similar to the UH-1C. The transmission is located directly ahead of the engine and is suspended by pylon isolating mounts on structural supports extending above the power plant deck. The unit is coupled to the engine through a short drive shaft. The transmission provides drive angle change and speed reduction through a train of spiral bevel gears and two-stage planetary gears to drive the main rotor mast. A freewheel clutch in the input quill coupling disengages to allow main rotor and gear train to turn freely when engine is stopped or is idling below rotor driving speed, such as in autorotational descent. The AH-1G uses the Huey universal transmission. It is the same basic transmission as used on the UH-1 helicopters, except that the AH-1G has no main generator. The starter generator is used as the main generator. A separate film in this series on the AH-1G covers the Huey universal transmission. It details where the quills, which are particular to individual aircraft, are located and how these should be installed to adapt the basic universal transmission to any Huey helicopter. The complete engine and power transfer system is enclosed in an easily opened or quickly removable lightweight cowling. The turbine engine and its accessories are located after the transmission and are mounted on a platform deck to provide maximum accessibility for servicing and maintenance. The T-53L13 series gas turbine engine is a free turbine type, flat rated at 1100 shaft horsepower. Flat rating refers to the limitation on the engine due to the airframe. The engine itself is capable of 1400 shaft horsepower. The engine consists of the usual 5 sections: inlet, compressor, diffuser, combustor, and exhaust sections. The bipod and tripod engine mounts on the AH-1G are the same as on previous Huey helicopters. The tailpipe is surrounded by an ejector shroud that extends several inches past the end of the tailpipe. This ejector mixes cool air with the exhaust gases to reduce the infrared radiation. The open end of the tailpipe is directly above the tail boom and directed slightly upward so that a view of the hot end of the turbine is possible only from a position that is above and behind the helicopter. 2 similar but separate hydraulic systems are used to operate flight control power cylinders, stability augmentation system servo actuators, and the armament turret. Systems number 1 and number 2 are exactly alike as to their reservoirs, transmission-driven pumps, and module assemblies. If one system is disabled, the other system can still operate normally. In addition to operations for both systems, hydraulic system number 1 has the following special functions: tail rotor controls hydraulic cylinder, yaw stability augmentation system servo actuator, emergency collective hydraulic power provisions, and cyclic controls accumulator and lockout valve. Hydraulic system number 2 has the following special functions: armament system hydraulic power provisions, and pitch and roll stability augmentation system servo actuators. The electrical power systems consist of a DC and an AC system. The 28-volt direct current supply system is a single conductor system with a negative lead grounded to the helicopter structure. Alternating current is supplied by one 100-volt ampere single-phase inverter that converts the 28-volt DC to 115 volts AC to the SAS system, fuel quantity, gyro compass, attitude indicator, AC fail relay, and 26-volt transformer. The 26-volt AC transformer, in turn, supplies AC to the following: fuel pressure, engine oil pressure, transmission oil pressure, torque pressure, and heading indicator. The primary flight control systems are the main rotor collective, fore and aft cyclic and lateral cyclic, and the tail rotor controls. Each of these is a system of mechanical linkage assisted by hydraulic servo cylinders connecting the pilot's and gunner's control sticks and pedals to those mechanisms which rotate with and directly control the main rotor and tail rotor. Obviously, the tandem seating configuration of the Huey Cobra will pose some complications in control rigging, since the system must be more complex than the side-by-side seating of earlier UH-1 aircraft. The AH-1G stability augmentation system is a three-axis stability and control augmentation system integrated into the conventional helicopter fore and aft, lateral, and directional flight controls. SAS provides a highly damped airframe during wind gusts and weapons recoil and was designed primarily to provide a stable weapons platform. One of the systems on the AH-1G, which is completely different from previous Huey models, is heating and ventilating. The crew compartments are ventilated by air drawn through a screen on the front of the pylon fairing and forced through the distribution system by a continuously operated transmission-driven blower. Air is distributed through adjustable ventilators on both instrument panels, vents to sides of canopy, and cushions of crew seats. Air leaves the compartments through a blower opening located in the aft bulkhead. Heat is provided by bleed air from the engine compressor system. Bleed air is also used through windshield nozzles for rain removal. Rain removal from the windshield is accomplished by setting the selector switch on the instrument panel to rain removal position. When the selector switch is in the rain removal position, no bleed air flows into the crew compartment. Armament is the Huey Cobra's reason for existence, and it has a great variety. Let's start at the chin turret. The TAT-102 armament subsystem is a hydraulically and electrically operated system providing wide angular coverage and rapid fire. The weapon is a 7.62 millimeter hydraulically powered automatic multi-barrel minigun. The weapon incorporates 6 barrels and 6 bolt assemblies which revolve about the longitudinal axis of the weapon. The weapon with the delinking feeder is mounted in the turret and is capable of short bursts or prolonged firing at rates of either 1,300 or 4,000 rounds per minute. The gunner's fire control panel is located in the co-pilot gunner station in the right deck, forward of the flight controls. The sighting station consists essentially of a simple compensating sight head and hand grip assembly attached to the aircraft floor by means of a 5 degrees of freedom support structure. The ammunition feed system consists basically of ammunition box assemblies, a crossover feed assembly, a flexible ammunition chute, and a synchronized cartridge drive assembly. The ammunition box assemblies are mounted in the aircraft aft of the turret assembly. The external stores pylon installed on the AH-1G equips the helicopters for carrying various external stores or weapons. The ejector rack of the pylon is equipped with an electrically operated ballistic emergency jettison device in each inboard and outboard ejector rack. The ejector racks must be cleaned at the end of each firing day in which the emergency jettison is used. The orifice in the outboard ejector rack must be replaced after each second jettison of stores. Installed in the AH-1G is the XM-20 smoke grenade dispenser, which releases standard smoke grenades used for spotting and identification. This dispenser is loaded with M8 or M18 smoke hand grenades by the armament crew prior to flight. It consists of 2 clusters of 6 canisters, either of which may be selected by the pilot. The wings each have 2 hardpoints for ordnance stores. Armament currently qualified for use includes The XM-157 launcher, which fires 7 2.75-inch folding fin aerial rockets. Also the larger XM-159 launcher, which can fire 19 rockets of the same type. Both types of launchers are reusable. Inboard hardpoints on each wing can accommodate the XM-18 minigun pod. The gun fires 7.62 millimeter ammunition. Both the gun and the feed system are powered by a self-contained electrical system. The mix of weapons will change depending upon mission requirements, since the variety of armament available provides an extremely versatile attack capability. Your TM-20 contains complete requirements for special inspection, test flight inspection, overhaul and retirement, and the standards of serviceability for the AH-1G. There is flexibility in performance of these inspections to allow for the variety of climate and terrain in which the Huey Cobra will serve. The Army TMs, your -20 and -35 handbooks. Use them and be sure to add the periodic revisions to the books. Don't forget, the pilots of your unit depend on your skill and dedication.